Nat Budin. We both used to work at a company called Patients Like Me. I was formerly director of engineering there. I'm now at Wistia. It is an excellent place to work. I'm based in Boston.
And I'm Nat Budin. I was formerly a principal software engineer at Patients Like Me on Amy's team. And I'm now at ActBlue, which is another excellent place to work. And I'm based in Seattle. I work remotely. I was working remotely when I worked for Amy as well. This talk is about a project that we did while we were both at Patients Like Me. Throughout this talk, you'll see these rectangular boxes that Keynote provided us. We call them Hindsight boxes, because this is the Hindsight track. And they represent a lesson that we think we learned from this experience, and we'd like to impart to you.
I do want to give a little bit of a content warning. If you've ever seen me speak before, I do speak pretty frankly about mental illness. I have bipolar disorder. That's relevant to the story we're telling. If this is hard for you, take care of yourself however you need to. We won't be offended. Let me tell you a little bit about Patients Like Me. It is a social network for people with serious, life-changing, sometimes fatal, sometimes chronic conditions. It's a place where they track their symptoms and treatments and the progress of their condition. But for most of the people who come to it, what they're really coming for is connecting with other people who are going through the same thing they are, for support and for information that will help them live better lives.
So this is a screenshot that I found on my laptop from roughly 2013 of what the development version of the site looks like, hence the lorem ipsum you probably can't read and the broken image that you probably can't see. But this is from the news feeds on the website, and in order to help people connect with each other, with people with similar conditions, Patients Like Me has Facebook-like social news feeds. And this is one of the big things that helps people on there. When they were originally built, before I came to the company, probably in like 2010, 2011 or so, the idea was based on this concept called data-driven journaling, or DDJ. And the concept there was that rather than just going to your newsfeed and making a post about what's up with you in sort of a free-form way like you might be used to, you would instead do this via updating your medical history. So let's say you add a new treatment for the condition you're on. The site would prompt you and say, what changed? What would you like to tell people about this? And you could choose to write something about it, and that would go to your newsfeed along with the update. So donating data while connecting with other people is the idea. And one thing about this that was kind of interesting is that it would make the newsfeed post regardless of whether you chose to write something or not. We'll come back to that later. And this is kind of how it worked on the back end. This was a very classic Rails monolith. There was a table in our Postgres database called stream event. It contained all the posts on the newsfeed, each one in a row, and they had the user-generated content that people had written when they made the event, as well as any metadata about the medical change, and that linked back to the medical history tables. And then when the controllers went to render your newsfeed, when you went to look at it, they would make a SQL query to figure out what you should see based on what you're following.
This was slow. It just kept getting slower, too. So it was slow because it was doing a join on something like 8 tables. We tried to make it faster by denormalizing some information, the IDs of conditions that the stream event was relevant to. We denormalized them into an int array column in Postgres. But in order to index that, we had to use a Postgres indexing extension. This did buy us some speed. It only took us so far, and the indexing extensions caused problems when people were provisioning new Postgres instances, either in production or on their laptops. Eventually, despite this, we started seeing 30-second to 1-minute load times. This is very embarrassing to say, for our heaviest users on login, because feeds were the first thing you saw when you logged into the site.
Yeah, so in order to fix that, we decided to do the thing that I think a lot of Rails developers would do when you're faced with an expensive request, and that's cache the slow, expensive part. And so what we did is we cached the results of the query that decided what stream events you should be seeing. We used Redis. We made a bunch of sorted sets, one for each user. And then we pre-calculated the results of all of those once, and then as people made new posts on the feeds, we would calculate who should be seeing it and add that to the front of the sorted set. And that actually worked pretty well. It took us down from 30 seconds to a minute for initial page load down to less than a second, which is what you'd hope to see. And so we were pretty happy with that solution for a time.
The problem was there was a growth cap here. When we initially set up Redis, we didn't really know what we were doing with it. And so we didn't set it up to be clustered. We set it up in some way that made it really hard to later cluster it. And then later, when we were running out of room, we didn't think that we could take a lot of downtime to do the clustering, and we also weren't sure that we could do it right that time either, because our ops team was super busy moving all of our infrastructure to AWS, and they didn't really have a lot of time to address this problem. So the other problem with this is that because we were pre-storing query results, anytime a product manager said, hey, can we change these queries, we would have to rebuild everything. So we weren't able to change the feed algorithms to surface better content, say content that had anything at all written in it. So we kept buying bigger and bigger machines to put this single instance of Redis on, and eventually we just ran out of being able to do that. We could no longer throw money at this problem. So we had this urgent technical problem. We started truncating people's feeds to save space. And we had no obvious solution at this point.
So this is around summer of 2016. We started to think that something like Cassandra or one of the other column stores might be the answer to our problem. We didn't really know anything about those either, but we'd heard they were good. So I got this email about a conference happening in Seattle around that time, very fortuitous. It was called Data Layer. It was a one-day conference at the MoPOP. And it was just focused on column data stores and NoSQL data stores and all this kind of stuff that I was interested in learning about for this. And so I asked to go to it, and I went. And I heard a bunch of talks about various people's experience with different data stores, and it kind of went the same way all day. We tried Cassandra, we tried React, we tried MongoDB. It was great. It did everything it said on the tin. It sped up our queries. It performed as it was expected to. But our ops team is unhappy. They don't know how to maintain it. This is new stuff. They don't know how to configure it. They don't know how to tell if they've configured it right. And the last talk of the day was from the Art Genome Project. And they had gone through a similar experience. They'd gone from a MySQL database to one of these NoSQL databases, and then they actually went back for those operational reasons. They just couldn't maintain the thing that they'd gone to. And what they decided to do is go back to their SQL database and just index everything in Elasticsearch. They'd been thinking of Elasticsearch as a full-text search engine before that, and so they hadn't really been thinking about this as a possible solution to their big multivariate ID queries. But it turned out to actually work pretty well for the problem, and it scaled out really well. This is kind of the promise of Elasticsearch. And it worked pretty well for them, and I was like, kind of sounds like us. So it happened that there was a hackathon week coming up at Patients Like Me at that time, and I made this proof of concept. And I just took our entire stream events table and indexed it in an instance of Elasticsearch, and I transferred ownership of that table to a new microservice I was building called Newswire. And basically, this worked almost the same way as the old system, except that the stream events no longer lived in PLM website. They now lived in Newswire. Newswire would index them in Elasticsearch simultaneously to storing them in Postgres. And I wanted to expose a querying API, rather than just have an endpoint that says, give me the feed for so-and-so. That would mean that Newswire would have to have knowledge of what the feed for so-and-so would be, and I knew that there was a lot of appetite for playing around with the feed algorithms at that time. So I wanted to make a querying API, and so I figured I could either reinvent GraphQL or I could use it. So I used it. And the thing I kind of take away from this is that sometimes the answer to technical issues was in front of you all along. We, like the Art Genome Project, we had been thinking of Elasticsearch as a text search engine. We already were using it in-house for exactly that purpose, and it was working really well for us already, and we already had operational knowledge of how to maintain it. But we weren't thinking of it for this problem because we were thinking about it the wrong way. And so hearing that conference talk at Data Layer really expanded my solution space, and I was able to see the solution that was in front of me. So I had this proof of concept, and I just kind of kept working on it. It was easy to do. I was remote. I was in Seattle. Nobody was looking over my shoulder.
Sort of me,
yeah.
Sometimes.
Yeah, like once a week we had phone calls, and that was it. That was my oversight. So I just kind of kept working on this thing. I was theoretically on another team, but who cares?
Let's pause here. Why did we do this as a service extraction? Well, we had a big old monorail, as many people do, and it was hard to make changes in. So it was really easy for people to say, why is engineering so slow with making changes? What's the engineer's problem? Around that time, pretty much the answer in the air to that was, try microservices. I think there is a debate to be had about whether that is the correct solution or not, under what circumstances, but we knew we wanted to try this and see if it helped. Since we had to rewrite feeds anyway, that seemed like a good project to try to do a service.
The other reason that we wanted to do a microservice is because we had a bunch of coupling already built into the feed system. Because this kind of was built as a way of tagging arbitrary text onto medical history changes, you can see a lot of places where that might be useful to somebody. And they didn't want to build another one, so they just made a stream event for it. And then they had to make sure that that stream event wouldn't show up in people's feeds, so that made the query even more complicated. And it just got really messy to deal with. And there was a lot of things that shouldn't have been stream events but were because it was convenient at the time. And we didn't necessarily trust our future selves not to do that again unless we pulled it out as a service and made a real boundary. Pretend boundaries are real easy to violate. And I want to take a sidebar about pretend boundaries. We are very close friends. We were very close friends at the time. We'd been very close friends before Amy was my manager. We thought we were policing the boundaries between our friendship and our work relationship pretty hard, but they were pretend boundaries and they were impossible not to violate.
Our friendship made it impossible for me to do something that I subsequently came to see as a crucial part of leadership, especially on projects like this. And that's to lead with realistic optimism. You want to present to the team, hey, there are some real issues, let's think about how we're going to solve them, but I'm confident that we can get through and solve them. Whereas in this case, as our project dragged on, stay tuned, my anxiety went way up and my mental health was way down, and all of that emotional stuff pushed onto Nat, which made things worse for him. So I learned from this project how important it is as a manager to really manage the emotions that I am presenting to the people who are reporting to me. They are not the right people to dump that on.
But pretend boundaries are easy to violate. Amy couldn't have avoided dumping those emotions on me because we were so close that I couldn't help but read what she was feeling. And that's one reason why when I left PLM, we both mutually decided that it would be better if I didn't come to work for her again, because we now have a real boundary between our friendship and our work, and that's made both our friendship and our work a lot stronger.
All right, returning to our story.
Okay, so I'm working on this proof of concept. Nobody's really stopping me. And Amy asked me how long this might take to bring it to production. I was like, 3 months? And as we all know, engineering estimates are highly reliable.
I blithely accepted Nat's estimate without too much digging, because honestly, that was easier for me at the time. If he had said what was really in his mind about how long it might take,
6 months.
It would have seemed just pointless to even start, right?
So why skunkworks in the first place? Well, for my part, I wanted some autonomy. I had just come off of a big, weird, messy project that was widely perceived as a failure, and I was feeling pretty vulnerable about that. Frankly, I didn't feel comfortable with other engineers looking at my code and looking over my shoulder and giving me feedback while I was doing it, and that's not a great reason to do something like this, but it was where I was at the time. I just wanted to go off in a hole and work on my own code base, and I wasn't fully conscious of that, but that was what I was in fact doing.
Meanwhile, getting leadership buy-in to get a fully staffed project that wasn't skunkworks seemed super hard to me at the time. It appeared to be a purely technical re-architecture. We wouldn't be shipping any features with it, certainly not immediately. And in a lot of startups that are trying to figure out how to make money, that's not really an attractive project to try to sell and get funded. Also, I was managing, for the first time, sort of more projects and people than I had managed before. So I didn't have a lot of bandwidth to get a properly staffed project and pay really close attention to it, frankly. So Nat said, hey, I can go off in a hole and fix this problem for you. And I was like, that would be wonderful, Nat, please. I would like to say, in retrospect, that we shouldn't have started this project as skunkworks, but I'm not really sure how things could have been otherwise, and we'll come back to that. But from that not fully conscious choice came several hindsight lessons. The first one is that you really need to market your project and get buy-in. You know, these days, if I think there's a big technical project that needs to be done and I can't get people to agree to staff it properly, I'm more likely to say, all right, well, let's wait till there's a time when it makes more sense to do this. The second thing is that you should never start a project with a single engineer. Single engineers who are not showing other engineers their code get real weird. Jess talked about this a little bit in her keynote, the way it's like a downhill creation process, but sort of an uphill analysis process. So what happened was when we did finally get staffed and some other developers joined the project, they were like, what? We don't understand. And a lot of stuff actually had to be rewritten so that other people could understand it more easily. And that is not a reflection on Nat. That is a reflection on what happens when someone is holding all of the context in their one head. The other thing that we really weren't able to do that would have been useful was to get specialists, QA, infra involved early to sort of point out the things that they were going to need to work on and things that we could change to make everybody's lives easier in the long run. And we couldn't really do that because we didn't have a real project. So if we got them involved early, it was sort of on volunteer time, and that's just really hard to do.
So why didn't we do any of these things? Well, it's because we fell victim to a classic blunder, the skunk cost fallacy.
Skunkworks projects seem like they will cost less, but in the long run, I think they often cost more. It is definitely less work up front to start a Skunkworks project. And it seems like it's going to be easier later when you can go and say, hey, we're 90% done with this project. Can you just fund us the last 10% of the way? But skunk bites can be nasty. First of all, people don't really like it when you say, hey, we've been quietly working on this thing, but now we need resources for it. and you feel kind of stuck, right? Because maybe your management is falling victim to the sunk cost fallacy and doesn't want to like waste the 90% of work we've already done. You're just going to need that buy-in eventually, because you are eventually going to have to be able to get QA and infra and other people on the team. And the work that you're going to have to do after you get that buy-in and they come on the team and point out all the things you didn't think about is actually going to be more work overall than if you had planned for it up front. So again, if we had gotten the buy-in, we could have had others on the team from the get-go, and the later work we did around infra, around QA, around helping other developers understand the code not wrote, we could have skipped.
So I'd said it was going to take 3 months at the beginning. So where were we after 3 months, Amy?
It was not ready to ship, but something good happened. The product manager who was responsible for increasing engagement on the website, basically he believed that the best way to do that was going to be experimenting with the feeds. And he was pretty new, so when he showed up, we were like, yeah, Nat's over there making that possible. But eventually he got very tired of hearing that. And he was like, no, how can this go faster? And I said, well, you can help me get a whole team funded here. So at that point in January, 3 months in, we got a couple extra engineers to work on the project.
And at that point, we had to rewrite most of the code I had written. Sorry.
So now it brings us to March, April 2017. We're 6 or 7 months in. We are still not ready to ship. This is kind of dark times for us.
One thing that happened around this time is that 2 additional requirements emerged. One of them was that we were going to have to deploy this with 0 downtime. I wasn't planning on this from the beginning. I thought we can take the feeds down for a few hours and migrate the data over. It would make everything a lot easier if we did. And it would make it faster to deploy if we did. But it turned out we weren't going to be able to do that. I'll come back to that in a moment. We also found out that we were going to have to keep supporting the old unmaintained iOS app. So it emerges is kind of a funny phrase to say, right? I should be able to tell you how these requirements came about. I actually don't know how we decided that we were going to have to do this with 0 downtime. I suspect that a lot of what was happening was that these decisions were being made in phone calls and meetings. I'm sure I was there for them. I don't remember what happened in them. I wasn't writing it down. And so here's a little mini hindsight lesson. If you think you might be proposing a talk to RubyConf about your project in the future, do a better job documenting than I did. But that did happen, and we brought a DevOps expert on from another team to help us figure out how to do that. The iOS app, I do remember how this happened. I'd been involved in creating the original iOS app years before this. It was this cool prototype project. We wrote it in Objective-C, which will give you some idea of when we wrote it. And then we kind of just didn't maintain it because it was a lot of work to maintain. We didn't really have a lot of Objective-C expertise in-house. And it seemed like not that many people were using it. We had maybe a few hundred users at that point by the time that this requirement came into place. And we decided that since we were web developers, we were going to focus our energy on making the best responsive web experience that we could. We were looking at progressive web app stuff. And there was a change in strategy from the company. And this does happen in companies. There is sudden changes of strategy. There are good reasons for it. There was a good reason for this one. We decided that we were going to have to build entirely new iOS and Android apps from scratch. And while we were doing that, we didn't want to make the experience of people who were using our existing iOS app worse. So we were going to have to maintain compatibility with that app, which we didn't think we were going to have to do.
So around this time also, patience is really running out for when is this going to ship. There's no actual end in sight. I knew that these 2 new requirements were definitely going to take more time, but I didn't really know how much. And I wasn't in a great position to figure out actually how much more time they might take. I had entered a severe depressive episode, but I was still trying to work, I was still trying to do my job, and I was also on this 2-month-long wait list for an experimental treatment for depression involving ketamine infusions. So I'm just really, I'm pressured to pick a date. I did pick one, but not really based on any good ideas about how long it would actually be. From the 2 additional requirements that came sort of late that Nat spoke about comes a hindsight lesson, which is that it's best if you can tie your choices to actual business needs rather than professional orthodoxy. I'm not sure that either of those requirements were really business needs. We wanted 0 downtime deploys because that's how the real engineering teams did it. And we felt that if we took downtime, we were not as good. We weren't doing it right. And that, I think, is kind of, there's always something like that, right? Those engineers over there are doing it the right way, and we're not good enough. You know, generally, there was just not very much tolerance for downtime because of that. Even though we had taken downtime before for major migrations, it didn't have negative effects. And bluntly speaking, our outages were essentially free. We didn't lose any money when we were down. And our most engaged patients, if we had said, hey, come back tomorrow for a better social feeds experience, all would have been like, okay, we'll see you tomorrow. Likewise, with the iOS app, I'm not sure that the rework that we had to do to keep that old app maintained for, 2 or 3 months longer while we were making the new apps really, wildly contributed to sort of a positive business outcome. So I would have pushed back harder. I try to push back harder now on things that I'm not sure are real business requirements.
But the date that Amy has picked, June 2017, does come around, 9 months into our 3-month project. And 2 very important things happen. We ship Newswire to production, and Amy begins her ketamine infusions.
So I went to work for the first 2 hours of this complex migration. And then I went to a ketamine clinic, and I actually was tripping for a couple of hours, which is a part of ketamine infusions. And then when I came out of my trip, I immediately slacked Nat. How's it going?
And it actually went pretty okay. The big problem that we had, the only big problem that we had is that we had under-provisioned our Elasticsearch cluster a bit. We thought we needed 3 nodes. We actually needed 5 to cope with the load we were getting. And that turned out to be pretty okay because our DevOps expert had planned for this, and he had made a way for us to just spin up some more nodes. So he did that, and it started striping across the cluster. It did exactly the thing Elasticsearch is supposed to do, and everything was fine after that. And also, we'd built enough resiliency into the integration that Newswire being partially out didn't actually take out people's news feeds entirely on the website.
So a lesson I take from this is that when you have a successful project, especially one that is a long, complicated technical project, most of which never ship at all, right? When you actually ship, but the result is that your users notice nothing, you really have to sell that success internally so that people understand that you did an impressive thing that was a success, even if it did take too long and annoyed everybody in the process.
Yeah, and as a corollary to that, success often feels like failure when you're going through it. In mid-2017, we felt really shitty. We were overdue on our project. We were doing work nobody would notice. We were annoying the ops and QA teams. And by the time we shipped, we were pretty demoralized.
So we really couldn't have sold our success because we didn't feel like it was successful. We needed someone else to do it. And in fact, someone did. One of the other directors of engineering there, she was very clear that she believed the project to be a success, and she told other people that. So sometimes you need other people to sell your successes because you're just in a place where you can't do that. And it's really nice to have those people have your back at that time.
But life went on after we shipped. So fall 2017, we started doing the thing our product manager had wanted to do in the first place for 9 months. We started tweaking the feed algorithms. We got remember those stream events that people had just like updated a symptom and there was no text, they chose not to write anything? We were able to actually get those out of the feeds, and users loved it. It increased user engagement. And then we also launched our new iOS and Android apps that those new teams had started writing, and because the news feeds were doing well after that change, they ended up centering the news feeds as their primary experience in the apps. Winter 2018, we spent paying off a lot of tech debt that we accumulated over the rewrite. We made major performance improvements, again, increasing user engagement. We actually got like a 2 to 3x speed boost from this. And spring 2018, and I say this was actually not me, this was a product manager and another engineer, figured out that it's possible to build an entirely new type of discussion experience on top of Newswire, which they called topics. And think less of Facebook news feeds and more of Reddit or Stack Overflow or something, where people are talking, having conversations back and forth about relevant medical topics for their condition. And this was enabled by having built that flexible query API in the first place. I couldn't have possibly thought of this in 2016. And it was an emergent use that just came out of our actual business needs. Here are some things that people said about Newswire afterwards. A software engineer on the project said, "My second tour on Newswire when we built tons of shit super fast. It's one of my favorite PLM memories." And a product manager said it was great to see how the big upfront cost enabled us to quickly launch new beta features. So,
success. A year after release, pretty much everybody thinks of the project as a success. Our bet paid off. The flexibility we built into the system, its separation from the main site, did make people be able to move faster. They really enjoyed working in the code base. They were able to give product the features they wanted. But every big technical project is a bet. You don't know if or when it's going to pay off.
We were lucky. We did a lot of things that in hindsight we wouldn't. And it actually still worked out for us, but it might not have, and many of my bets in the past haven't worked. And by the way, that's not a reason not to try things. Just, sometimes you don't know all the things you should know, and it doesn't work out, and it's a bet, and not all bets pay off. So what did we learn from all this? A lot of things. We put them in rectangular boxes, but for many of those lessons, there were reasons why we did the things the way that we did at the time. Everyone has their reasons. We blamed ourselves for our failures, but
projects and people are part of a system. It's easy to say, if only we'd done X, next time I'll be sure to do Y, make a nice checklist, here's what to do when you're starting your service extraction project. But in reality, at the time, we were limited by a lot of things: our industry, our company, our own personal, what was going on in our lives at the time, our relationships with others within the company and within engineering. There were reasons that we did things the way we did, so it's not so easy to say, oh, if we could have gone back, we could have done it differently. Maybe if we'd thought more systematically about what some of those constraints were, we could have done something different, but maybe not. The good news is that you don't actually have to know what you're doing to sometimes be successful at it. Most of us don't know what we're doing most of the time, both as developers, and that's also just the state of being human, right? We've never lived our lives before. And that's okay. Sometimes you're able to succeed anyways.
So in conclusion, be kind to your past self. They were doing their best. I want to take a brief moment to acknowledge everybody who's worked on Newswire over the years, including up to today after I left the company. We actually have one of them in the room. Hey, Stephanie, could you wave? She took over tech leadership of this thing after I left. Thank you so much, Stephanie. And thank you all very much. If you have questions, please talk to us after.